for an identity. So chapter 8.4, Trigonometric Identities. All right. When I first took this class, this section was very hard for me at first. I actually ended up not learning this until the class was over, which was a very real shame because it got me a C in that class. I regret doing that, but I won't forget. I didn't like it, so I avoided it. So when it came to the test, these were the only ones I left blank, and I got screwed on exam 2 and on the final because of it. But my teacher was very old school. He was the type of guy that would throw chalk at you if you don't listen, and he did not allow any kind of formula sheets. He expects you to memorize about 60 plus identities and formulas or derive them before the test starts. But since I'm letting you have a formula sheet, this shouldn't be that as hard as it was for me, I hope. All right, so establish the identity. So most of the questions on the homework, honestly, the homework won't be very good practice because you need to work everything out. So when you get to the homework problems, make sure you do it on paper and then punch in the answer, because I doubt that homework is able to do this justice. So here's the identity. So they're saying, show that this is true. Basically, that's what you do. Prove this statement is true. So what you have to do is choose one side and stick with it, and then try to show that it's equal to the other side. Usually you want to pick the most complicated side, because if you pick something too simple, then it requires a lot of imagination to get to the other side. But if you have something to work with, you should be able to get over here. So I'm going to pick this side. So write down the side you're choosing for your notes on the exam or whatever, your scratch work, I mean. So start on the left-hand side. So then, first step is to show that this is equal to sine theta times cosine theta over sine theta. So from here to here, I use the quotient property or identity. Okay, so you have to have the formulas that say sine over cosine is tangent and cosine over sine is cotangent. That way you can change it. And then from here to here, you can see that they're going to cancel, right? So these cancel. So from there to there was just algebra, right? We didn't do anything special. So we're only left with cosine theta. That's what we wanted to show. So we wanted to prove that this side is indeed that side. This is what you need to show on your exam. Okay. Is there any questions about this problem? Okay. Let's keep doing a bunch of these because they get more and more difficult. All right, so here is this question here. Cotangent theta plus tangent theta times sine theta is equal to secant. We'll show that this is true, and you should always choose the most complex side so you have more to work with. So I'm going to choose this side, right? So here we go. So start by writing the side you chose. And then begin to show. At this point, once you choose a side, you basically need to try something. And this is the part that's hard to teach, because what do you try? is always the question. And when you do a few of these, you start to see certain techniques at certain times. But the thing you should always do is just try anything, see what happens, and go down a weird algebra rabbit hole. And sometimes it'll work out, and sometimes you'll see you took a very difficult path and you should start over, and that's okay. So when I see this, I say, well, I could probably change these guys into the quotient property, right? Cosine over sine, sine over cosine. I could try starting with that. So let's see. So this is cosine over sine plus sine over cosine, right? So I use the quotient property from here to here. Maybe identity, I forgot what the book called it. All right, so at that point, when I see these fractions, I always feel like we should add the fractions before we do anything else and see if it helps us. So the LCD is sine cosine, right? So you're going to add these, you're going to introduce the LCD that you need and then add the fractions. So to get cosine down here, I'm going to multiply the top and the bottom times cosine. And then I'm going to multiply the second fraction to get a sine down there by sine. Sine theta over sine theta. So right here inside is the LCD going on. So then we get cosine squared theta plus sine squared theta over sine theta cosine theta. So from here to there, I did the LCD add fractions. That's what we did. We added the fractions with the LCD. You guys have any questions? I know sometimes you guys forget the fraction stuff. So do you see how we got to there to there?
So you use the reciprocal on the second one?
Here, so from here we need, we can't add the fractions because the denominator is different, right?
Mm-hmm.
So I introduced what I needed. So right here, the LCD is actually sine theta cosine theta. So in order to get sine cosine, I need to multiply by what I need. So this is missing cosine in order to get this, right?
Yes.
So I multiplied top and bottom by cosine to force the bottom to be this. And then I needed a sine down here, so I multiplied by sine. And then once I had them on the bottom, you can just cosine times cosine is cosine squared, sine times sine. You're able to add the fractions. So there's a mini step I skipped. This is the step I skipped here. So when you add these guys, right, you will just add the top part and leave that alone. So that's how I got to here.
Mm-hmm.
Does that make sense?
Yes.
Okay. So cosine squared plus sine squared, we should know what that is, right? You guys remember?
1.
Yeah, that's going to be 1. So that's gone. Then we have sine theta cosine theta times sine theta. Right? So from here to here, it was the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. I'm going to erase this just so it doesn't look too cluttered. Okay. So that gives me here, multiply this out, right? The algebra. And we're left with 1 over cosine, which we know is secant. And that's what we wanted to show. Let me move this camera. Okay. Does that make sense?
Yes.
Do you have any questions on any of the steps? If I lost you somewhere, let me know. Okay. I think of it as some weird kind of Sudoku, but it feels like a game. If you know all your properties, then you can play the game, right? Let's go to the next one. Okay. Same question. Establish the identity. Okay. Let's pick this guy. Sine u cosecant u minus sine squared u. Let's pick them out of focus a bit. That is equal to cosine squared. So I'm going to pick the left-hand side because that looks more difficult, more complex. Okay. All right, so first things first, let's try using the reciprocal, I guess, because whenever I start these, I never know how to start. I just try something. So I see that this is a reciprocal, right? So let's try applying that. So that will be sine u times 1 over sine, right? Minus sine squared u. From here to here, we use the reciprocal identity. Right? Cosecant u equals 1 over sine. Okay. Now they're going to cancel, right? So sine u times 1 over sine minus sine squared u is equal to 1 minus sine squared u. So here to here was just basic algebra, right? Fraction canceled. Now here, what is 1 minus sine squared? It's one of the Pythagorean identities.
Doesn't it equal cosine squared?
Yeah, that would be cosine squared. From here to here, we should know that cosine squared u is equal to 1 minus sine squared. Pythagorean. Is there any questions about any of these steps for number 3? Oh man. Sorry, got distracted. Guys okay on 3? Okay. All right. Example 4. Same deal. Establish the identity. Okay. Cosecant x plus cotangent x equals sine x over 1 minus cosine. Okay. I'm going to take the left-hand side. It looks like it could, since I know these can be changed to like fraction kind of things, it makes me want to choose this. Because I'm able to do something that's clear. That's the other side. I don't know what I would do. So let's pick this guy. All right. So cosecant x plus cotangent, this will be 1 over sine x, right? Plus cosine x over sine x. Now, these are the same denominator, so you can go ahead and add them. That'll be 1 plus cosine over sine. From here to here, I use the quotient identity. Quotient, yeah. And then I just added fractions. Right. Okay. So the next step is a technique you use when you're not quite sure, or you see a sum on a fraction. So what you do is multiply the top and bottom by a conjugate. Conjugate meaning the same thing but minus. So you do top and bottom. So 1 minus cosine because I have 1 plus cosine. 1 minus cosine because I did it on top. So let's do it to both. What this does is guarantee a difference of squares. That's why I chose to do this. So multiply by conjugate. So that will give us 1 minus cosine squared x over sine x times 1 minus cosine, right? What is 1 minus cosine squared?
Sine squared.
Yeah, sine squared. So we're going to end up with sine squared over sine x times 1 minus cosine x. So from here to here was the Pythagorean again. But I'm running out of room. So notice how these signs will cancel, right? So that will give us our final answer. Sine x over 1 minus cosine. This is what we wanted to show. Is there any questions on any of the steps on number 4 or 3 or 4?
That one was kind of hard because the conjugate, I don't know, I'm not used to that.
Yeah, so the conjugate is one of the techniques that you will use. So sometimes when you're out of ideas and you see like a 1 plus something, like 1 plus sine and 1 plus cosine, try this out and see if it helps. Also, the first thing you should try when you see them is check, like, okay, can I use a quotient to create fractions and then add them? It's usually a good route. But when I added them, I ended up here. And I'm like, wait a minute, I don't know what to do next. Like, how the hell do I change this into this, right? That's the goal. Like, they're similar, but they're not the same. So that's when you decide, all right, you know, let me use this conjugate idea. Because 1 plus, as we know, right, back to our algebra basics, we know that a plus b times a minus b is a squared times b squared, right? Back from developmental math, right? So that's what we did here. A plus b times a minus b gives us a squared minus b squared. A squared is 1, so that doesn't matter. So that gives us the ability to use Pythagorean. Excuse me. Okay. All right, let's do one more.
Can you give me 1 second?
Yeah, sure. There's no rush here.
Thank you, sir.
Okay. All right. So I don't know exactly how they're going to ask you on the homework, but it's hard to show or do these kinds of ideas because there's no one way to do this. Like, you can choose many different paths and you still get to show equality. But the best path is really the shortest path. But the best path for you will be the one that makes sense and gets you there, right? Who cares? But if you notice the path you take gets really complicated, maybe start considering starting over, picking a different route, trying something different. Because remember, you're trying whatever you want and see if it works. And sometimes we miss obvious things when we restart. All right. 1 minus cosecant x over cotangent x minus cotangent x over 1 minus cosecant x.
Can you lower the notebook? It's too high.
I didn't see that. 1 minus cosecant over cotangent minus cotangent over 1 minus cosecant. So this will be 2 tan x. So obviously you're going to pick the left side, right? But let's take a short break here. Come back in about 10 minutes. 6:37. Come back at 6:47. So right now it looks complicated. So just think about it. First thing is I see 2 fractions, so I should probably add them together. So I'm going to pick the left-hand side and go from there to figure out how to add them. So LCD is going to be cotangent times 1 minus cosecant. So I need to introduce these in order to have the fractions, right? So this guy has the cotangent. It does not have the 1 minus cosecant. So I'm going to introduce it here, top and bottom. This one has 1 minus cosecant. So I'm going to introduce cotangent, top and bottom. So here we go. 1 minus cosecant x over cotangent x times 1 minus cosecant over 1 minus cosecant minus cotangent over 1 minus cosecant, so multiply by what it's missing, which is cotangent. So we will get 1 minus cosecant squared on top, right? It's 2 of them, over the LCD cotangent times 1 minus cosecant minus cotangent squared over cotangent x times 1 minus cosecant. So now I can add them together. So we will get this nonsense, 1 minus cosecant x squared minus cotangent x. You can write it this way if you want, who cares? All over cotangent x times 1 minus cosecant x. All right, you guys still with me, right? So all this right here was just adding or subtracting, right? Fractions. So that wasn't anything new, but there we are. Now we have a bunch of stuff on top. Let's try squaring all of it and seeing if we can do something. So I see that this will be 1 minus 2 cosecant plus cosecant squared x when you FOIL this first part. And I'm going to leave the other one as cotangent squared. So here we did some algebra. Now cotangent squared is, there's a Pythagorean identity for cotangent, right? Using the Pythagorean, cotangent squared is equal to cosecant squared x minus 1. So I'm going to replace this guy with this because I want because I see a bunch of cosecants, right? So it's probably better to have everything in terms of cosecant. So that's what I'm thinking right now. That's my strategy. Oh yeah, don't forget the bottom part. It's still there, right? Cotangent x 1 minus cosecant. So we're going to get 1 minus 2 cosecant plus cosecant squared minus cosecant squared x minus 1. Right, we're plugging that in there for the substitution. LCD is still down here. So here to here, we use Pythagorean. Okay. Now we'll do some algebra to combine the top part. So you have a negative there, so that would distribute. So we're going to get a plus 2 and a minus cosecant. So 1 minus 2 cosecant plus cosecant squared x minus cosecant squared plus 1. So this will cancel, right? Leaving me with 1 plus 1 is 2 minus cosecant x. That looks a little bit better. Maybe I'm on the right path here. I hope. So once you get here, oh shit, that was a 2 on there, wasn't there? Okay. Minus 2 cosecant x. There you go. All right. So now it looks like we're almost done. Because I see they have a 2 in common, right? So I can factor that 2 out. So that will give us 2 times 1 minus cosecant x over cotangent x times 1 minus cosecant. So these are going to cancel right here. So from here to here, it's just algebra, by the way. Algebra. So these will cancel, leaving me with 2 times 1 over cotangent, right? Because that's going to be 1 over that. I'm separating it on purpose so you can see it. Because this right here is tangent. This will be 2 tan x by the reciprocal identity. Okay, there we go. Now, is there any step along the way that didn't make sense?
I just feel like that one is pretty complicated, and I probably would have stopped halfway through and thought that I'm going down the wrong path.
Yeah, sometimes that happens. Like you just, if it starts to get a little too crazy and you don't see, the horizon, I guess. Sometimes that happens. This is one of the harder ones. I want to do one difficult one at the end, at least. But you'll have a ton of different types. But yeah, you'll have to keep practicing the basic ones first. After a while, you'll start to see the identities.
Yeah, so when you ask if you have questions, I'm like still writing and I don't really know what I'm writing, so I have to go over it. And I watched the recordings, I was like, oh, I do have a question, but I'm not in class anymore.
No, I get that. I mean, if you want to hold off writing, I'll send you these later. Either way.
Oh. Yeah, so I think everybody kind of does the same. Like we're still writing down. And you're like, any questions? And we're probably still writing it down.
I feel like I wrote the same thing like 4 times.
Huh?
What's that?
I feel like I wrote the same thing like 4 times. Like just copied and copied and copied.
Yeah, I mean, I wrote it multiple times so you can see like the details. Because I mean, I could have skipped steps, but skipping steps is not going to help you.
Oh no, we don't want that.
Got it.
Because this right here, I mean, I could have just combined these into one step, but I don't want to be like the book where they just skip to the end.
Mm-hmm.
Let's see. Let's try another one. Because again, it's all about practice, right?
Yeah.
Okay. Now let's do another conjugate type, I guess. Yeah, there's something similar to this one. So this one was a little harder, right? I don't know what number I'm on, but whatever. Yeah, what? Okay. So sine theta plus over 1 plus cosine theta plus 1 plus cosine theta over sine theta is equal to 2 cosecant theta. So right away, left side looks like a good one to choose, right? So let's start here. What would you guys want to do here?
Common denominators.
Yeah, I think common denominator is a good route. So LCD, what is the LCD? Right, since these are prime, it's always going to be 1 times the other thing. Just both denominators together for these types. Okay. So this guy needs a sine, and this guy needs 1 plus cosine, right? That's what we're going to do. We're going to introduce it on the next step here. So sine theta over 1 plus cosine theta needs that sine. We haven't done this one, have we? Looks familiar.
Yeah, we did one.
Oh, okay. Yeah, we haven't done this, right? Sorry. Got paranoid. It looks similar like one of the second or third ones. All right, so this needs a sine, and this guy needs a 1 plus cosine. Okay. So I introduced the LCD here, right? Okay. So then we will get sine squared theta over the new LCD here. 1 plus cosine times sine plus 1 plus cosine theta squared over 1 plus cosine theta sine theta. There we go. Okay. So now we're just going to combine the fractions, right? Okay. So we will have sine squared plus 1 plus cosine theta squared all over the LCD. Okay. All right, so here we just combine the fraction, right? Or add them, in other words. All right. So apparently I'm not sure what to do, but I do see that we could FOIL this out, right? Let's start with that and see if we see something helpful. So we will see FOILing that out, right? 1 plus cosine, 1 plus cosine. That gives us 1 plus 2 cosine plus cosine squared. Yeah, all over 1 plus cosine theta sine theta. Okay. So what do you guys see? What's the next step we can do here?
The sine squared and the cosine squared can add to equal 1.
Yeah, that's a good idea. So sine squared theta plus cosine squared is 1. So we'll get 1 plus 1 plus 2 cosine, right? All right. So here to here, Pythagorean. So that'll be 2 plus 2 cosine over 1 plus cosine sine. All I do is combine 1 plus 1. That step is probably not necessary, but oh well. We can factor 2 though, right? That will be 1 plus cosine theta over 1 plus cosine theta sine theta. So these will cancel, leaving me with 2 over sine theta, which is the same as 2 times 1 over sine, correct? Which gives us 2 cosecant quotients, or actually reciprocal.
So on the test, will we have to label all of this stuff on the right?
No, I won't make you tell me what you did, but I will expect to see a lot of steps.
Okay.
But yeah, but I really recommend you have all the identities ready for your exam, because there's quite a few, right? You
Yeah.
don't have to memorize.
Can you lower the book a little bit?
Downward?
Yes, over there. Thank you.
Okay.
I'm sorry, sir. When you say we factor out the 2, I'm having a brain fart and I can't see what exactly is going on in there.
It's kind of like if you had 2 plus 2x, right? If I factor a 2 out, you would get what? 1 plus x, correct?
Oh, okay. Yeah.
So it's the same deal here. Pull out the 2, you're left with 1 plus cosine.
Okay.
Yeah. All right. This will stop here. Let me take a look at your homework real quick before we start. Before we stop, rather. Stupid homework. Okay. Yeah, whenever you do the homework, the ones that matter are the ones that tell you establish the identity. So the first like 8 or so, actually the first like 10 questions is just doing algebra, the first 7 questions rather, just doing algebra to figure out the simplification of your expression. And after that, they start doing these kinds of problems. So I skip straight to the proofs because that's what you're gonna need to know. So on your exam, you'll have just nothing but these. So question 8 through 20, I recommend you do it on paper and then go back and, you know, punch in the answers or whatever. Okay. I guess we'll stop here. If you have any other questions, you're welcome to stay for a bit. If not, I'll see you Monday.
Thank you.
See you later.